With the enormous impact that artificial intelligence models have in science, technology, and society, many people are looking for ways to make these models more transparent in order to better understand what is happening on the inside of these models. In the field of explainable AI, researchers have come up with many different tools to help achieve these goals. These tools are called interpretability methods. Very recently, a new generation of interpretability methods have emerged that have been specifically designed to be applied to transformers, the model that is underlying many of the recent breakthroughs in AI, including large language models such as ChatGPT, Llama, and Mistral, but also image generators, music generators, speech recognition systems, and much more. Before we dive into the details of interpretability methods and the advantages of these new transformer-specific methods, let's first talk briefly about what we may want to use such methods for. Consider, for instance, the use of generative AI to make personal recommendations for new music to listen to or new books to read. Often, the recommendations are not entirely to the satisfaction of the user. But how can we offer the user a way to change how such recommendation systems operate if the system is a black box? Interpretability tools may offer a way to open up the black box, discover interpretable concepts on the inside that correspond to a user's mood or to genres of music or literature, and help provide knobs that the user can turn to make the recommendations less cheesy, more upbeat, or a little more classy. Or to give a completely different example, consider the use of AI techniques in job search and recruitment. AI can be used to match CV and job descriptions, but to use such systems responsibly, a minimum requirement would be that we can guarantee that such systems don't make use of so-called protected attributes, such as gender or ethnicity, and that job candidates get some insights into the criteria that such a system uses and receive feedback on what job skills they would have to develop to improve their chances in the future. To give insights in how such models arrive at their output, many feature attribution methods have been introduced in the last decade. There are some success stories about how such feedback has revealed that the target model was using problematic shortcuts. However, in recent years, and certainly since transformers have become so important in AI, these feature attribution methods have also received much criticism. One frequently made observation is that the explanations they generate may often look plausible to human observers, but that such plausibility is not at all a guarantee that these explanations also correspond to the real causes inside the target model. In other words, plausibility does not imply faithfulness. Another frequent observation is that in practice, different feature attribution methods often disagree radically, despite the fact that each is based on strong theoretical motivations. And with all that disagreement and skepticism about using plausibility, it is unclear which of the many methods to use in practice and how to measure the faithfulness of each method. Hence, we are at a crucial stage in the field of explainable AI. On the one hand, AI has made massive advances, and companies, governments, and institutions worldwide are rushing to deploy large language models, foundation models, and other generative AI techniques. The technology finds usages in society ranging from automatic customer service to job search and recruitment, from writing support and automatic translation in medical and legal practice to music and movie recommendations. On the other hand, the models used in all of these domains remain black boxes, and interpretability methods are, as of yet, failing to provide a reliable, valid explanation for how these models arrive at their outputs, even in cases where the stakes couldn't be higher. Understanding the limits of interpretability methods as well as finding ways to understand more of what is happening under the hood of transformer models, is therefore crucially important for both engineers and policymakers. In this series of videos, we explore the state of this exciting field.